Hi everyone, today we're gonna talk about the Earth's rotation and time zones. So remember, rotation means spinning. The Earth rotates on its axis and it rotates counterclockwise or eastwards towards the east side. Now, we said the Earth rotates eastward, and because the Earth rotates eastward, we experience sunrise and sunset first towards the east side of the Earth, and sunrise and sunset towards the west side of the Earth. So, kind of like this, the Earth rotates from west to east, and as it rotates from west to east, the eastern part of the Earth, whichever location is more towards the east side, will experience sunlight first. Therefore, the sun will look like it's rising first in the sky, and that location will also experience sunset first, meaning that location will move away from the sun before any location in the west does. So, in this case, A is moving towards the sun first, sunrise, and it's also moving away from the sun first, sunset, before B even experiences the sun. Okay, so let's go back a little. So, time zones are what humans created because the Earth's rotation causes different parts of the Earth to experience daylight and nighttime. For instance, as the Earth rotates, some parts of the Earth are experiencing sunlight and experiencing daytime, and some parts are experiencing nighttime. But the whole world, all the people in the world, want to have the same language on, or the want to be on the same page on which time is in which location, because if it's daytime on this side and nighttime on this side, they both can't have the same time. So we created time zones, which are our concept of time based on the location of the Earth in relation to the sun and the Earth's rotation. So, when the part of the Earth that's right next to the sun is normally experiencing noon, and the part of the Earth that's opposite the sun is normally experiencing midnight. And then, as the Earth rotates, the part of the Earth that's starting to see the sun is close to 6 a.m., and the part of the Earth that's starting to move away from the sun is close to 6 p.m., and so on. So, make sure you have your note packet out with you and write this down. Time zones are based on Earth's rotation eastward. Go ahead and pause this video. So next, Earth's rotation happens from west to east, and it also rotates 15-degree longitude every hour. Remember, one full rotation is 360 degrees in 24 hours, so that means as the Earth is rotating, it's rotated 15 degrees every hour, as we've seen before. So go ahead and write this down. The Earth rotates eastward at 15 degrees longitude per hour. When we're looking at the hours or how long it's rotating, which way, we're looking at the longitudes, the vertical lines, not the latitude. Also write this down. As the Earth moves 15 degrees longitude per hour eastward, it actually affects the time at different longitudes, but does not affect the time in different latitudes. So when we're focusing on time zones, we're only looking at the longitudes, the vertical lines, and not the latitudes, because the different longitudes, the different vertical lines, are what creates the different time zones, just like this. So this part of the Earth would have a different time, 15 degrees, and then the next 15 degrees would have a different time, and so on. So this is why, as the Earth rotates 15 degrees every hour, when we created the concept of time, we also said that time will change by 1 hour every 15 degrees of longitude. So if I'm going from here to here, from 0 to 15 degrees, my time will change by 1 hour. And then another 15 degrees from 15 to 30, my time will change 1 more hour. And then between 30 and 45, which is another 15 degrees, my time will change another hour, and so on. So with every 15 degrees of longitude, the vertical lines from north to south pole, my time is changing by 1 hour. So go ahead and write this down. 15 degrees longitude per hour affects time in different longitudes, and a 15-degree change in longitude will be 1 hour time difference. And latitudes, the horizontal lines, have no effect on time zones. So let's say this is the Earth and this is the North Pole. We're looking at the Earth from the North Pole. This is the western side of the prime meridian. This is the eastern side of the prime meridian. And now we split the Earth into these sections to figure out what time is going to be in each location. Remember, the Earth rotates 15 degrees every hour, and we said that when we created the concept of time, time will also change 1 hour with every 15 degrees of change in longitude. So one thing you should remember is this wheel, WEEL, which means west is earlier and east is later. Meaning, if I'm starting from the prime meridian, as I'm going west of the prime meridian, every 15 degrees west I'm going, my time is changing by 1 hour earlier. And every 15 degrees east I'm going from the prime meridian, my time is changing 1 hour later. For instance, if this is 0 over here, 15 degrees later, my time will be 1 hour later. And then over here, another 15 degrees, my time will be 2 hours later, and so on. And then from the prime meridian, if I'm going towards the west side, then my time will be 1 hour earlier every 15 degrees. So from 0 to 15 degrees west, my time will be 1 hour earlier. And then another 15 degrees west, my time will be another hour earlier, and so on. So say from 0 to 15 degrees west, right here, my time is noon. Notice that I'm not just looking at the lines, I'm looking in between the lines, okay? So from 0 to 15 degrees west this way is noon, this whole area. That means if I move another 15 degrees this way towards the west, my time will be 1 hour earlier. West is earlier. So if this area, the zone is 12 p.m., towards the west of 15 degrees, my time will be 1 hour earlier, so 11 a.m. Another 15 degrees earlier or towards the west, my time will be 10 a.m. And then another 15 degrees for between 45 and 60 is 9 a.m. And then another 15 degrees between 60 and 75 is 8 a.m. and so on. I'm looking in between the lines, not on the lines. So every 15 degrees in between, every area in between 15 degrees will be an hour earlier or later. So let's start at 0 again, which is noon right here between 0 and 15. If I go another 15 degrees towards the east side, my time will be later. So if 0 to 15 degrees west, this area is noon, then 0 to 15 degrees east is 1 p.m. And then 15 degrees east to 30 degrees east is 2 p.m. 30 to 45 degrees east is 3 p.m. and so on. So every 15 degrees, my time is being 1 hour later between the lines. Okay. And by the time we get to international dateline, that normally starts the next day. So notice that if this is 12, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. From 165 degrees east to 180 degrees is 12 a.m. or midnight, meaning after 180 to 165 degrees west, I have 1 a.m. the following day. And this is another map that shows the same concept. The prime meridian is normally 0. Every 15 degrees east of the prime meridian we're increasing the time by 1 hour. And every 15 degrees west of the prime meridian we're decreasing the time by 1 hour. My time is coming earlier. Remember, this is just a concept. This is human time. It's not affecting when sunrise and sunset is happening. And we're always looking between the lines. So from here to here would be 1 hour later than what the prime meridian time is. Here's another example. So if this is 2 in the United States, then if we're going eastward, my time will increase, right? This will be 3, 4, 5, 6, and so on. The US has 4 time zones. If we're just zooming into the US, we have Pacific, Mountain, Central, and Eastern. And let's write that down. In the United States, we have 4 time zones. Pause this video. And notice we're using the same concept. The west is earlier, east is later. Say we start at Central Time, which is 4 p.m. As I go west, every 15 degrees or every time zone that I'm moving west, my time is earlier by 1 hour. So if this is 4 p.m., my next time zone west is 3 p.m., my next time zone west is 2 p.m., and so on. And remember, east is later. So if I'm going east, my time will be later. So if this is 2, this is 3, 4, 5, and it's changing by 1 hour every 15 degrees or every time zone. Also notice if you're on the same time zone, same longitude, right? For instance, for Fargo and San Antonio, it's going to be the same time because they're on the same exact time zone, this green area. But if I'm comparing this blue area versus the green area, which are 2 different time zones, they're going to have different times. So if 2 locations are on the same exact time zone within the same 15 degrees, then it should have the same time. Okay? Now, once again, you have different times that we created to be on the same page with each other as humans. That does not affect when sunrise and sunset is happening. Yes, A, say this is location A and this is location B. Location A is 5 p.m. is at 5 p.m. Location B, Pacific, is at 2 p.m. Just because locations A's time is later doesn't mean that location A will experience sunrise and sunset later. Location A is more towards the east, right? Remember, the Earth rotates from west to east. And as it rotates towards the east, let's go back a little. As it rotates towards the east, locations towards the east side are experiencing sunrise first compared to locations towards the west side. So A is experiencing sunrise first because it's closer to the east, and B will experience sunrise later because it's closer to the west. And let me show you a closer look. This is A, right? Since A experienced sunrise first, A already experienced 6 a.m. first, right? A is also going to experience 5 p.m. first and then 6 p.m. first. And even it's going to experience sunset first. All right. It's going to experience sunset first before B even experiences sunrise. So location A further east will experience sunrise and sunset first. Location B further west will experience sunrise and sunset later. But when it comes to creating time, A's time will be later. For instance, A will be 5 p.m. in this case versus B, which will be at 2 p.m. because A already experienced most of the day and experienced sunrise first before B even started the day. Okay. So while A is already on the other side of the sun, B is just starting to see the sun. That's why A is at a later time when it comes to creating time or a human time, and B is just starting time, right? It's just starting the day. That's why when we're writing the time, B has an earlier time, A has a later time, even though A is experiencing sunrise and sunset first because it's towards the east. So go ahead and write this down. West is earlier time, east is later time. Remember the wheel, WEEL. West is earlier, east is later. But that does not affect sunrise and sunset because sunrise and sunset happens first on the eastern part of the world. Let's write that down. Sunrise and sunset happen in the eastern part of the world and later in the west. Pause this video. And noon will always be next to the sun's rays. Okay, so as the earth is rotating from west to east, the part of the world that's right next to the sun's rays, that's experiencing direct sunlight at that moment, you'll have noon. Okay, and sunrise and sunset in this example will happen in location D first because it's farther east compared to C, B, and A. And that's it.